right. So I wanted to jump in and talk a little bit about Chapter 3, kind of give a brief overview of Chapter 3. So as we get into it, we're going to start using SQL now to start building queries and do things with a database. Now SQL is a popular and widely used language for retrieving and manipulating data in databases. Back in the 70s, it was known as SQL, S-E-Q-U-E-L, and then in the 80s, it was quickly shortened to SQL, S-Q-L. Now SQL is used by most database management systems, and you'll see that there's a little bit of a flavor for the different ones. We're going to be using Oracle in this class, so the flavor of SQL that we use will be the flavor that's typically used with Oracle. Now most of SQL is the same, but like I said, there are small differences here and there for the different DBMSs. Alright, the Oracle Database 11G Express. Now this is software used in our text to illustrate SQL. These commands will work in the same in other versions of Oracle. In fact, I tend to use the latest and greatest Oracle Express Online, which I believe is version 18 now. Don't quote me on that. We'll jump into it. Sometimes they change literally in between semesters, and I'm using the most modern. Alright, differences between Oracle and Microsoft Access and SQL Server, they are going to be noted in your text and sometimes even in these slides in these special boxes. It is worthwhile to know the differences, especially for some of the quiz questions. There will be some quiz questions that may ask you the difference between how you might do something in Oracle and Access. But for our knowledge and what we're going to be doing as assignments, it will be all Oracle. So using the Oracle Database 11G Express Edition, again, I like to use the app that loads in your web browser, and you have to get signed up for that. And I recommend everyone use their mail that they get with SBC. The reason being is Oracle tends to approve those almost automatically when they see that your email address is coming from a institutional organization like SPC. But you don't have to. It may just take a little longer for your Express Edition to get it approved. And then you're going to create a workspace, and that's the space you're going to log into. You're going to see me do that when we do our exercises. It will become very natural. For the most part, you'll be able to do everything we're going to do in class in Express Edition online. There are a few things, because you can't elevate to a high enough permission, that you won't be able to do. I'll make sure to mention those things, and for the most part, they're not really part of our assignments. I think there's one or two, and I'll let you know what those are. And if you're using the online, not to worry. Just script out what it should look like, and that's what you would submit. You wouldn't actually run it. So when we get into developing a database, one of the most common first things you're going to do is create a table. And to do that, you use the create table command. We're going to get into this. We're going to show a couple examples. We're going to show how you define type and size of data within the columns. Alright, so creating a table, we're going to talk about the table and how you create column names and some restrictions. For example, names cannot exceed 30 characters. They must start with a letter, can contain letters, numbers, and underscores, but cannot contain spaces. So here's a good example of a script to create a table. At the top, you can see this create table, and rep is the name of the table we're going to create. And then in parentheses, and you'll see way down here is the in parentheses, are the column names. So here we're saying we want to create a column name rep underscore number, space, the type that this column is going to be, which in this case is a 2-character wide char column. And we're also going to specify that it's the primary key by putting this word primary key out here. Make sure you put your comma. This will be a place where you're going to mess up on occasion. It's going to drive you nuts, but you'll figure it out and you'll get used to that. And so here's the next column, last name, char of 15 characters wide. We've got a first name, char also 15 characters wide. A street, char 15 characters. City, char 15 characters. State, which is char of 2 characters wide, postal code char 5 characters wide, and then a commission decimal 7 comma 2, which means it's 7 digits wide with 2 places for the decimal. And this rate is decimal 3 characters wide with 2 decimals. Now this semicolon is important. It says that you are done with your command, and that when it runs, it should run all of this before the semicolon as one command. If you forget your semi-command, most of the time the commands will run, but I will tell you, for cleanliness as well as completeness, make sure you put your semicolon on there. I may take a point off if you forget to do that in your assignment, especially just to kind of remind you to make sure you're doing it. So here's some additional pieces of information when you're creating a table. Commands are free format, no rules stating specific words in specific positions. Indicate the end of the command by typing a semicolon. We just talked about that. Commands are not case sensitive. What you're going to start to see is that a lot of people will use a particular case when developing their SQL. A lot of times the commands are all in caps, as well as tabbing. It's not required, but you'll start to see that people get more comfortable with that, and makes your queries look a little bit more readable. So you'll see me doing it in different formats and different styles, just so that way you can get used to the different styles. But typically most students pick up a style and go with it. In Oracle, enter the command in the SQL editor pane, and we're going to do that here in a little bit, probably in another video, to show some examples. So here's what the command looks like in one of the older versions of Application Express Online, but for the most part, Oracle Application Express Online is similar to this and looks about the same. So it's still a good representation. You're going to have your command line up here, where your command panel, I should say, where you can put in your SQL command, and then you're going to be able to run it. I think the run button is now way over here on the right, and we'll show some examples of this here in a moment. And then you'll get this message that says table created, or you're going to get an error, in which case you'll have to figure out the error. It will be a little bit cryptic at first, and oftentimes I find that the error will be on a line after the actual error. So if it's complaining about this postal code line per se, oftentimes the line above it, the state line, is what it's really complaining about. I know it seems a little silly, but it gets something that you have to get used to. Don't be afraid if you can't figure something out to shoot it over to me to take a look at. I'll try to help you with it. Make sure you send the entire query for me. This is how you do it maybe in Access. So again, in Access you would write this query and you hit run. For us, it's not too much that we need to worry about, and this is an example of doing it in Microsoft SQL. As you can see, for the most part, the SQL is the same amongst the different systems. And it is, I would say, about 90%. I'm throwing that as a rough number out there. But you will see that a lot of it's the same. In fact, most people that can write SQL in one system can fairly get along in another system. So correcting errors in SQL commands. Use the same techniques that you might use in a word processor. Take pieces out, put pieces back in, make changes and click run button to execute the command again, and then check results panes to determine if command succeeded successfully. Dropping a table. Now for the most part, we don't really use dropping a table all that much, and you probably won't either. In fact, right now is about the only time you may use the dropping of the table, other than to maybe specify some examples. But if you create a table and for some reason it doesn't go right, or you don't like it, you're probably going to have to drop the table before you can recreate it. And that's typically where we see dropping the table. In a lot of companies, deleting data and dropping tables is a big no-no. There are ways to archive off data, but typically deleting data is considered a bad thing. So you can correct errors by dropping a table and starting over. It's useful for when a table is created before errors are discovered, and the command is followed by the table to be dropped in a semicolon. Any data in that table is also deleted, so be careful of that. Data types. Now, when we were creating those tables, we had to specify different data types. So here are some of the more common data types. We got the char in, which is basically saying, hey, make me a char column of n characters wide. So if I need something that's 30 characters, I would put char 30. Now char is very basic. It handles the most basic ASCII characters, where most people use the varchar, which is a little bit wider and allows for more characters, characters that you might find in foreign language sets possible as well. Then you've got the date field, which is just as it says, a date, which typically includes a time. Then you've got the decimal, P of Q, and that's precision, as well as, I forget what the Q stands for, but it's the position out to the right of the decimal. An int is an integer, which means it has no decimal. It's just a 32-bit integer. And then small int is same thing as int, it's just smaller width-wise. We really don't use small int much these days anymore. Space is not as considered as expensive as it used to be. Back in the olden days, we used small int because we wanted to have smaller fields, if possible, to save on disk space. Nowadays, we don't typically use small int. We just use int. But now you know what a small int is. So using nulls. We do have this special value in our SQL in Oracle databases that allow us to represent data that actually isn't data. So this is a special value to represent that situation when the actual value is not known for a column. It's not blank, because blank, believe it or not, is actual data. It's a string of no characters, not a null. Null truly is an absence of data. You can specify whether to allow nulls in individual columns. So when you're creating your tables, you can say, hey, this column doesn't allow for nulls. Primary key is a good example where you wouldn't normally allow nulls. Now, the upside of primary keys, by the way, is it automatically specifies that nulls are not allowed, so you don't actually have to say that in primary keys. But any other column that you want to make sure it doesn't allow for nulls, you'll have to specify. Should not allow nulls for primary key columns. That's what we just talked about. So using nulls. Use not null clause in the create table command to exclude the use of nulls in a column. So that's how you say that this column cannot take a null. A default is to allow nulls. And if column is defined as not null, the system will reject any attempt to store a null value there. It rejects the entire attempt. So if you're trying to write a insert query and put data into a table, and you try to put a null in a column that doesn't allow for nulls, you'll just get back an error. So here is this similar query we did before, except in this, again, the char2 primary key, we don't have to put the not null. It's already assumed, and so your primary key won't allow for nulls. But this last name and the first name, we do specify the not null. So we're saying in this table, last name and first name have to always be specified. If you have columns that you know that nulls should not be there, use the not null. Always make sure that you do this because you don't want bad data in your database. And this is one way to make sure bad data doesn't get in your database or nulls get in where they shouldn't be. So now we're going to add a row to a table. It's a pretty simple command. It's called the insert command. So we're going to insert into the table the values, and we're going to talk about those values. Remember that columns use single quotation marks for the values. So here's a good example. Insert into rep values, and this is the values. Now, one thing to show you, and I think we here in the next slide talk about this, but we're not specifying any column names. We're literally saying insert into rep values and all these values. That means when you do it this way, you have to specify a value for every column. You cannot skip any columns. They have to be in the same order that the table shows them in, and not doing so, you'll get an error. To add new rows, modify previous insert commands, use same editing techniques as those used to correct errors. Inserting a row that contains nulls, use a special format of insert command to enter a null value in a table. Identify the names of the columns that accept non-null values and then list only the non-null values after the values command. So here is what we were just talking about, where I'm inserting into rep, but I'm only specifying these three columns, which, by the way, these three columns have to have values. They aren't allowed to have nulls, so we have to specify at least these three and give these three values. The rest can take nulls, so we don't have to specify them, and we didn't have to give them values, and the system on its own will insert nulls instead of data into those columns. So now it's time to view data. So we're going to use the select command, and we're going to, in this case, we're going to use select star from followed by the name of the table. Now, with that being said, you will only use select star in very small instances. It's considered bad form to use select star because you are putting yourself in a position to select a bunch of data that you're not real sure of, and we don't like to get in the habit of that. So for the most part, select stars in most companies aren't really appreciated. So we don't tend to practice them either as well, just so we don't get used to using them. There will be a couple times you will use them throughout the examples, and the instructions are pretty specific about that. So here we're doing a select star from rep. So essentially this is saying select everything from the rep table. And that's what it's done. These dashes, by the way, are considered nulls. And in fact, it goes along the lines of, we go back, this is where we inserted the 75 Perry Annabelle with no other data, and that's why these are nulls. This talks a little bit about access in SQL. I'm not too worried about that. So now that you've inserted data, what if we need to correct errors in the table? Or what if we just need to update data? We can use the update command to update values in a table. The delete command allows you to delete a record, while the insert command allows you to add a record. So what they're kind of saying here is you can use the update command to correct errors, or you can also delete a row and then reinsert a row. Again, most companies are not okay with you using the delete command. It typically doesn't happen. We would use updates. We'd also just have more sophisticated systems in place to keep us from accidentally inserting data or updating data with errors. For the class, we will use some deletes and we will use some inserts in that manner. So in this case, we're updating a row, we're updating the rep table, and we're setting anywhere that the last name equals Perry. We're setting the last name to Perry wherever the rep number equals 75. So let me repeat that again. We're updating the rep table, and we're saying, hey, set the last name equal to Perry wherever you find the rep number equals 75. Now, because we know the rep number is a primary key, that means there can only be 175, we can see down here when we run this command, we got one row updated. If we select star from rep again, just to check our information, there we go. Row 75 has been changed to Perry. Alright, now we're going to delete from the rep table where rep number equals 75. Now again, we know that this column is the primary key, so it can only be once. There's no duplicates, so there's only one case or no cases of it being 75. But this is still a very dangerous query. It doesn't take much to make a typo and maybe accidentally change this column name to something else, and before you know it, you're deleting a bunch of rows of data. So it's very, very careful when you're using the delete command this way. In fact, I always recommend doing a select from rep where rep number equals 75 first. Make sure you see the actual line of data you're about to delete, and then comment out the word select and then type in the word delete so you can see what you're about to, you can see it and then delete the data. Saving SQL commands. So it allows you to use commands again without retyping. You can save out your SQL commands. You can save them in a text file. If you're saving it through the actual system, it will save it out as a text file with a SQL extension. But to be honest with you, you can save these out as in a text file because it's just text. And then you can load them back in either through a text editor, or you can load them in through the system if they have that SQL extension. It's great to have a script repository. Most companies, especially the application support team, will have a plethora of scripts that they've got saved somewhere to do small little actions behind the scenes that maybe there's no UI to do, but they may have to do it on occasion because they need to fix something that doesn't normally happen, so forth and so on. So they will have a repository of scripts that they've saved. And you can also create a script file in Oracle. And in fact, one of the things you're going to do this week is to load the data that includes all the tables plus actual data for the tables into your system that loads that Colonial database into your Oracle database. Doing so is going to be running one of these Oracle scripts. So once you've created that script, you can you can view it, edit, run, you can delete it, you can do all these things, including saving it to a repository. Access does not use script files. They use SQL commands as query objects. SQL Server is very similar to Oracle. You can create scripts, you can view, edit, and run them. So we're going to talk about this here in a little bit. We're going to execute some scripts to get the rest of the database into your system, and then we can even I'll show you how to run the drop of all those tables in case something goes wrong, so that way you can try again and reload them. Now in Oracle, we have this really cool function. It's called describe, and when you describe a table, it just tells you everything about the table. We're not going to talk about access in SQL Server because we're in Oracle, but the describe is very unique to Oracle, and it's something we're going to use quite a bit. So here it is. They're describing the rep table. It tells you the table, the column names, the data types, the length, the precision and scale. This, by the way, is when you have a decimal, you can say what the precision and scale is. Scale being how many digits in the decimal. It also will tell you other things like whether something is nullable, whether it's a primary key, if there's any default values that are entered, and so it's a pretty neat command. I use it all the time. So that is this chapter, chapter 3, and all the things that you're going to need to know. There will be another video in regards to running the scripts, as well as a video talking a little bit about some of the exercises we have for this week. Thanks for stopping by.